well, as an eager spectator and a peripheral participant. So I'm the director of this Center for Neuroscience. We've had a long relationship with Etienne, and of course Slavic is one of the co-founders along with me, and I'm very pleased to have just met Mark. The research that we're interested in sponsoring is essentially anything that's interdisciplinary and is concerned with better understanding the role of the mechanisms of mind. So we cover a lot of ground. My particular area of expertise is in language. I'm trained as a linguist, but also as a neuropsychologist, and I'm very interested in artificial grammars and the role that how we can exploit them in understanding the relationship with language and structured thought. But we have people working on affect. We have people working on decision-making, reward pathways. Huge range of topics that are going on at the center. And I really found that this particular project to be compelling. Actually, I generally find anything that Slavic's working on to be compelling. But I found this to be a very compelling topic. And it was a great opportunity to sort of fit well. We have a budget to promote interdisciplinary research, and I can't do anything more interdisciplinary than this. So I'm very, very happy to meet you here. I'm really looking forward to this weekend. And actually, all of the work has been done by Etienne, so we should make sure that we don't forget that. He's been doing that and feeding his newborn son. He's been telling me about his increased expertise in, what is it, eating a yogurt in 6 hours? How to eat a yogurt in 6 hours is the topic of his next talk. So I'm very happy then to whom I'm pointing. Slavic, you guys, are we launching, or are you doing another?
Yeah.
Go.
Just say a couple of words. It's my pleasure to introduce the first speaker this morning, which is an old colleague of Slavic and mine, going back a long time. We worked together in the Department of Cybernetics many years ago, and it's a great delight to ask Tom to come and open the conference today. And Tom's going to give us a provocation on connectivism. Thanks, Tom, first.
Is there a laser pointer or something?
Yes.
Great, thanks. Thanks, Bish, for the introduction. So Etienne gave me the task to kind of like map the terrain of Enaction for you. And so in this talk, I'm going to try to kind of like sketch where I see the framework growing to from all the way from single cell biology up to human culture. And of course, it's not going to be complete. I'm just going to try to point you in some interesting directions. I'll try to point out some areas where I think that we are doing better than the cognitivists have been doing. I'll try to point out some areas where I think that we need to do more work. And at the same time, I just want to convey some of the excitement that we can open up all these different areas with a new perspective and do some interesting work there. So that's why the title, Don't Look Back, Enaction is the Future of Cognitive Science. It's a bit provocative, but then there's an Enaction conference, so let's see how far we can push this thing. Go. So the overview of the talk. In the beginning, I'm going to try to introduce you to what I think are the key concepts of Enaction, and then I will talk about the enactive challenge of higher level cognition. This has been one of the maybe like most prominent topics in recent years because even though Enaction has done well in lower level cognition, the orthodox cognitivists say that, oh, we cannot talk about human level cognition, we need to have the old framework for that. So I'm going to suggest to you that actually the enactive approach does have a unique perspective also on higher level cognition. And the way that I'm going to try to address it is saying that maybe this notion of second order sense making could be one way of going about it. And then we'll put some concluding remarks and we'll see what the upshot of all of this is. So first, let's say we'll look at the foundational concepts. So what precisely is enaction? I'm taking here a quote taken from the recently published book Enaction, which is a collection of papers. And the editors of this book, Stuart, Gapen, and DiPaolo, have this to say: a living organism enacts the world it lives in. Its effective embodied action in the world actually constitutes its perception and thereby grounds its cognition. And we've heard this kind of description already for almost 2 decades now, so I list some references here. But also I think there are actually some related approaches which have a similar conception of perception. So here's the sensory-motor approach from the 2001 paper by Kevin Regan and Alvanoe, where they say that we propose that seeing is a way of acting. It is a particular way of exploring the environment. And activity in internal representations does not generate the experience of seeing. The outside world serves as its own external representation. The experience of seeing occurs when the organism masters what we call the governing laws of sensory-motor contingency. I think that's a very good summary of the sensory-motor approach. And again, we've heard similar things from robotics. So this is Brooks in his famous 1991 paper. And he concludes that, after having built a number of autonomous mobile robots, he says he came to an unexpected conclusion. He says, when we examine very simple level intelligence, we find that explicit representations and models of the world simply get in the way. It turns out to be better to use the world as its own model. So these are some examples of what he's talking about. This is one of the famous robots from the AI lab in MIT, one of his insect-style robots. And this is one of the robots from Wolf Pfeiffer's lab in Zurich. And these are really robust little creatures. There's interesting features, for example, these feet are not very slippery, but for some reason that makes it actually more stable than if you would give it more traction. So somehow the physical properties of the body of these robots can actually have a big impact on the controller of how we control the movement. So that's interesting embodied robotics. But when Barreda, Thompson, and Roche wrote about Rodney Brooks' robotics in their book, The Embodied Mind, they called it a completely, fully inactive AI. That's what they had to say about this robotics. And then Daniel Dennett, in his review of The Embodied Mind, has this to say: the trouble is that once we try to extend Brooks's interesting and important message beyond the simplest of critters, artificial or biological, we can be quite sure that something awfully like representation is going to have to creep in like the tide in large waves. Will our inactive enlightenment lead us to say different sorts of things about these sorts of cognitive states, events, and processes? Probably. Very different, revolutionarily different. It is too soon to say, so we won't know for a while whether we need or are in the midst of a revolution in cognitive science. That was almost 20 years ago. I think to some extent Dennett has a point. At least 20 years ago he had a point. Because if you look at the robots that Brooks is working on, that Barreda was talking about, really we had something like this. This is taken from Randy Beer's dynamical systems approach to evolutionary robotics. And he has this diagram where he carves up the space of the robot and the environment into 3 interacting components. You have the nervous system, which is usually an artificial neural network, which is coupled to a body of the agent, and which is coupled to the environment. And he says that once we adopt this perspective, we realize that the behavior of the system cannot be reduced to any single component. So normally, if you're a neuroscientist, you're very used to saying that everything reduces down to this part, But if you take a dynamical systems point of view, it's not so easy to do that. Actually, you have to look at all of the different components in order to explain what's going on. But notice that there's actually no difference between any of these components here. In fact, you could just draw the boxes slightly differently depending on where your interests are. Whether a variable sits in this box or in this box is not really crucial to his analysis. And in fact, nothing says here that this is, for example, an agent and this is an environment. You could just switch the whole thing around and say, why is this not the agent and this is the environment? There's nothing in this approach which can make that distinction for you. And that's a problem. And why is that a problem? Because we know that action is important. We know that agency is important. So here's a very famous work by Gaga. He made this device to help blind people see by kind of remapping the modality. So he has a camera like here that's getting fed down to transducer, and then he gets a tactile stimulation on his stomach. And he found out that people can learn how to see with this device if they're allowed to move the camera freely and thereby create their own sensory motor loops. And there's a lot of debate about what it's like to wear one of these. So actually, me and another fellow University of Reading graduate, Adam Spears, created this device here, the Inactive Torch. He started touring philosophy events, this is Adrian Cousins here, to give people a chance to actually experience for themselves what it's like to use one of these devices to feel your way around. And in case you're interested, I brought the latest version of the Inactive Torch with me, so later on in the break, just come and find me, and we'll try to blindfold you and you can try to see what it's like. You can have funny games with this. This was at the Inactive workshop in Battle, so here we have some of our fellow inactivists trying to, have a kind of interaction with the device. So it's different kind of things we can do. But the important thing is that these kind of devices show us that action is important. So we kind of have to understand what is the difference between an action and just a mere movement. If someone moves your arm for you, you won't have the same effect. So where does this intentionality come from? So we kind of need to go beyond embodied robotics. We cannot stay in Brooks's framework if we want to understand this. One way to try to make sense of what is agency is to go into the inactive approach. And here very nicely, in a paper by Paolo and Gaga, they said, Enaction basically involves these interlinked concepts. We have to talk about embodiment, emergence, autonomy, sense-making, and experience. And they're all interlinked. And when we start talking about these concepts, we kind of leave some of these other approaches to the side. So for example, it goes beyond just the dynamical systems approach of Randy Beer. They say, in order to distinguish an emergent process from simply an aggregate of dynamical elements, like in the diagram that I showed you before, two things must hold. The emergent process must have its own autonomous identity, and the sustaining of this identity in the interaction between the emergent process and its context must lead to constraints and modulation to the operation of the underlying levels. That's quite a mouthful, and I'll try to unpack some of this for you in the following slides. But you can already see that they're trying to reach for more than just coupled dynamical systems. And I think also we can make an argument that the inactive approach goes beyond a sensory motor account, at least in its original formulation. Here's the Paolo Borelli again. They say, autonomous agency goes even further than the recognition of sensory motor couplings as dynamical and emphasizes the role of the agent in constructing, organizing, maintaining, and regulating those closed sensory motor loops. In doing so, the cognitive agent plays a role in determining the norms that it will follow, the game that is being played. The question then is, what is an agent? And they give us a hint here already. It's something that is involved in the constructing, organizing, maintaining, and regulating the sensory motor loops. And in fact, we can really kind of like expand on this and these levels of agency. And we've tried to make a kind of conceptual analysis of the different notions that we need. And this is a paper by me and Ezequiel Di Paolo where we started at autonomy and then added additional requirements to say that, well, if we want to go from just purpose to sense-making, to behavior, to cognition, to social cognition, to culture, these are the kinds of things that we need. So we're increasing the operational specificity at each level. We're adding another operational requirement into the system. And that goes with a qualitative change. So there will be qualitative change going inwards here. But at the same time, every time we add a layer, also that layer will feed back on the underlying level, transforming the conditions of the system as well. So really, it's a complex mesh of different requirements. So I'll try to talk you through some of the levels here going down. And then I will make a jump and I will talk a little bit about sociality. So this is the picture that Vareda liked to use in order to illustrate what he meant by the notion of autonomy. So this is Escher's drawing hands. You have one hand drawing the other. Well, actually it's being drawn itself by the hand that it's drawing. So the idea is that you have two interrelated processes of construction or bringing forth that codepend on each other for their existence, right? So both of them need each other in order to exist, and only because they're bringing forth each other does the whole as a codependent network of processes exist at all. Okay, so if you look in the realm of biology, one of the most simple forms where we can find this kind of codependence is in simple cell metabolism. And that's where the idea of autopoiesis comes in. So autopoiesis in the biological domain is basically having a metabolic network which creates a membrane boundary around it which permits the metabolic network. So the metabolic network creates itself and it creates a boundary, and the boundary makes sure that the network doesn't diffuse into the environment and die. So both of these processes enable each other. And in more recent work, Vareda tried to go beyond just a purely operational description and tried to connect some of this work with his concerns in phenomenology. So in an important paper with Weber in 2002, he drew on Kant and said, maybe we can use autopoiesis to get a naturalized account of purpose. And Kant originally had to say, in such a product of nature, every part as existing through all other parts is also thought as existing for the sake of others and that of the whole. That is, as a tool, organ, an organ bringing forth the other parts, and hence everyone bringing forth one another. And only then, and because of this, such a product is an organized and self-organizing being and can be called natural purpose. And I think he was actually the first one to talk about self-organization. It's interesting that he linked it directly with purpose. He calls it a natural purpose. It's not purpose that we put into the system, it's the system itself that's bringing forth its own purpose. And when such a system exists and it creates itself, you can say that it creates its own identity on the level of the system as a whole. And that identity will have some relationships with the environment. So you can say that the process of self-production or autopoiesis also constitutes at the same time not just the identity but also a domain of interactions. And this domain of actions is evaluated in relation to the way in which the system creates itself. So this is how we try to connect behavior and normativity in relation to the self-construction process of the organism. And of course, not every interaction is the same. We want to distinguish between good interactions, bad interactions. So we need some way of regulating interactions such that the organism can maintain itself better. And this is the idea of adaptivity. It's something that Ezequiel Di Paolo said was missing in the original formulation of autopoiesis. Maybe it was implicit, but in any case, it's good to make it explicit, even if it was there. And the idea is basically that what we want to do is talk about the regulations of the interactions that maintain the identity. And that regulation can be metabolic, so you can internally reorganize yourself. So maybe, for example, to be able to metabolize other chemicals. It can be interactive, so maybe you can change your environment in order to be more suitable for you. It can be cognitive, and then you can have the nervous system to help you regulating your interactions and so forth. So there's different ways of implementing it. Okay, so I've talked about purpose, talked about the regulation of those interactions in relation to that purpose. And here we have a possibility of trying to link this biological account with actually some of the existential philosophy. In particular, Hans Jonas, who was a student of Heidegger, tried to see whether he could take Heidegger's phenomenology of being in the world and kind of ground it in this idea of the metabolism as something that is self-producing and concerned and purposeful. So I'm going to quote from Hans Jonas here. He says, our first observation is that organisms are things whose existence is their own achievement. That means that they only exist because of what they are doing. Therefore, the statement that the existence of organisms is their own achievement simply means the activity as such is their being. And the fundamental point of departure is that life says yes to itself. He's talking very poetically here, but I think he's making an important point. He says, in wishing itself to continue, it declared itself as a value. Maybe thus say that mortality is the narrow door through which value, the thing addressed by yes, entered the otherwise indifferent universe. Because the thing is that once you are not partake in it, there's nothing really that tells you, oh, you should continue to exist or you shouldn't continue to exist. So the fact that living systems are self-maintaining, that is, they're regulating the interactions so actually prolong and improve their conditions, that's what he's meaning here. Life is saying yes to itself. There's a kind of like drive there in order to continue existing through your activity. And in order to explain that, he says, this is really where we can start talking about values. So I've taken you through a kind of like little tour where we started with kind of Brooks-style robotics, where we don't really have a notion of agent. We're basically just looking at sensory-motor couplings. Then I introduced the notion of autonomy as a form of self-constitution. And now I've basically talked about the regulation of this structural coupling by a self-constituting system. And when we have those things together, I think we're justified to start to talk about agency. At least a very minimal form of agency. And don't forget that at the same time we've now said that when you're self-constituting, we can start talking about having internal purpose, internal value, and now with the regulation of the structural coupling, those values are related to the behavior of the system. So this is then how we get to the notion of sense-making. Here's Giovanni Colombetti, and she says, with respect to the environment, this means that the environment is never, for the living system, a neutral world awaiting to be internally represented and evaluated in order to become meaningful. Rather, the world is directly encountered as meaningful by the concerned living system. The world is always the living system's own meaningful Umwelt. So here she's connecting with the biologist von Usko, who coined this term Umwelt, to describe the meaningful environment of living systems. So, coming back to the enactive perception account, I think that you could say that in order to really ground our understanding of what enactive perception is about, sense-making is a really useful notion. And this is the kind of diagram that we could draw in order to really explain what we mean when we say action is constitutive of perception. Okay. And we can also I think when we ground enactive perception and sense-making, we're also leaving functionalism behind. So sense-making gives us the answer, why does the world show up for us? And for Albanoy, answering that question is actually answering the question of consciousness. Why is there a world showing up for us in our experience? That's for him is the crucial question of consciousness. And also, sense-making is a powerful concept because it allows us to explain the action. And I think we can say something about why are we susceptible to intentional blindness, because it's the meaning, the sense of the situation that's primary and not the objective facts and features of the world. And we can also say why it is that the dynamics of sensory motor loops are insufficient to ground perception. So we don't have perception in robots which just have sensory motor loops. And the important point is, although we can explain all of this, or we have a good handle of this, functionalists can't do the same. And that's because notional sense-making resists a functionalist appropriation, since it depends on the co-constitution of an identity in this context. This is the Froese idea. But more crucially, if you want to talk about value, it depends on mortality. So it's the fact that the system is only there because of its own identity, because of its own activity, that it exists at all. And it's this precarious situation of self-creation against the odds around you that we can say that here is the start of value and concern. And so mortality actually plays a key role here, and it's something that functionalism can't really get a hold of because it would be the sensation of all functions. That's what it is to die. So it's kind of like outside the scope of the functionalist framework. And so now that we have the notion of agency, at least in a minimal form, the question is, how do we scale it up to human cognition? Because really what I've been talking about could be applied to a single cell organism, right? So we're quite far away from human cognition. And there are several challenges that we need to tackle. What about non-metabolic values? If it's the self-creation of the organism that grounds purpose and value, how does it ever get concerned with something that is not related to its own metabolism? How do we ever get to abstract human cognition? If everything is meaningful, always primarily, how do we ever get something purely objective and abstract? So do we need to return to its inner mental representations as Denon predicted? I would argue not necessarily. I think there are other ways of scaling up this notion of agency and sense-making to human cognition, and the work I've been doing in the recent years is to see whether social interaction is one way where we can do this scaling. So, just to give you a brief recap, in this diagram, I'm trying to depict the history of the field of cognitive science. So in the middle, I placed cognitivism in the 70s, and then I placed an outer ring of connectionism, and then we started being embodied, and then inactive. And so we're kind of moving outwards in a bigger and bigger context. We're not just interested in computational things anymore. We want to talk about dynamics and emergence. We want to talk about embodiment. We talk about living and lived experience of things. So we're just adding more and more things that are of interest to cognitive science. And if you look at the first stage in the computational theory of mind, it also wants to explain human cognition. Its paradigmatic example is the psychology student under experimental conditions. And how relevant is it to understanding the human mind? Well, it's hard to say because as its model, it's taking the von Neumann architecture. So it's really thinking that you're something like this, some computer on legs. But stage 2, embodied cognitive science, has problems too. So Brooks was talking about Cambrian intelligence, and of course eventually he wanted to also scale up and talk about human cognition. But since robots were inspired by insect life, like a cockroach, its relevance to the human mind places us, the last common ancestor maybe 350 million years ago. So how relevant is that to explaining human cognition? Right? That's a problem. But now, with the inactive approach, it looks even worse. I've been talking about single-cell organisms. So you had Varela talking about life equals cognition, and of course he wanted to explain human cognition, but the paradigmatic example now is the single-cell organism swimming in a neutron gradient. So the relevance to the human mind is the origin of life suddenly, maybe 3.5 billion years ago. How relevant is that to talking about human cognition? It looks like the further we moved away from the center, the further we moved away from what we were actually trying to explain. So to paraphrase a famous paper that critiqued one of Brooks's paper, is it today autopoiesis and tomorrow man? Already Brooks had the problem of scaling up, and the light-mind continuity seems to even increase this problem. Because how can the same explanatory framework that accounts for the basic phenomena of living cells be extended to incorporate the highest reaches of human cognition? And in one of my papers, I argued, an active approach must develop a systematic response to this cognitive gap if it's going to be useful as a framework for cognitive science. But here's the thing. Actually, we can overcome the cognitive gap in about 18 years. We all start as single-cell organisms, and 18 years later, we can be psychology students. Right? So we're not talking about 3.5 billion years anymore, we're just talking about 18 years. So actually, we've narrowed the gap. It's just that we need to adapt a developmental perspective, rather than an evolutionary perspective. And I don't have much to say on that, but I think that this is really an important area for future research, to really work out what is an inactive developmental perspective. And another thing to say here is, another problem is that maybe the scalability problem, even for Brooks already, looks so difficult because the prevailing focus is always on the individual organism, on its own. Right? You have one robot running around in its maze, and that's your measure of intelligence. There's no social interaction there. So maybe we can make some inroads on this cognitive gap problem by looking at the role of sociality in enabling cognition. So we kind of start with this. We have the most basic form of agency, but of course we can also have two of them sharing the same environment, and both of them are regulating their sensory motor loops. But if they do it so that they depend on each other in their regulations, actually what they're doing is they're forming one shared sensory motor loop. Right? So we have a kind of interactional mediation between the two systems. They can affect each other's regulation. And moreover, this loop here can also form an autonomous organization of its own. Those two processes can also become codependent. And that's important because when we talk about social cognition, where you actually have the presence of another in your perception, so it's not just a multi-agent system with things interacting, but you actually talk about this kind of a decentralization of where you acknowledge there's another agency out there. We somehow need to be able to decentralize the sense-making and to kind of be able to allow another locus of agency to become available to your perception. And I think, but maybe the autonomy of the interaction process could be helpful here, because that's already a locus of external agency. Once the interaction process itself starts becoming a self-sustaining process, to some extent it's already constituting its own values that constrain and kind of pull the sense-making of one agent to be extended into a different direction. Okay, so the story that I want to tell from going from here to higher level cognition is basically one of adding more and more decentralization, adding more and more mediation. And the idea is that basically we want to look at ways of interfacing or mediating the regulation with the interaction with the environment. And I'm going to look at 3 examples of human and social interaction: language, writing, and technology. And I have a few words to say about each of those. But the main point is that when we talk about abstract human cognition, which was the mainstay of the cognitivist framework, of course it's the ultimate form of decentralized and mediated sense-making, but I think it's actually a secondary achievement. Right? It's the product of a very complex network of processes. It's not the starting point. And hopefully I will be able to convince you that this is the case. So, just a little image to try to show you what I mean when I say that primarily we engage with our world in terms of sense-making. So when you look at this image, there's different meanings that you can pick out. I guess some of you will see two old people looking at each other, but then there's also a Mexican party going on in their faces, you know, with guitar and tequila and some lady waiting in the background. Or you can just look at this vase thing in the foreground, right? So if I ask you now, what is the objective thing that you're seeing there? Can you please like draw objectively what you're seeing? Well, it depends on what you're making out of the image. You know, it depends on your sense making. Even though it's the same physical light stimuli coming to your retina, you can see this differently. Different sense making. And in fact, making objective representations is so difficult that a big breakthrough happened when the camera obscura was developed, because it allowed people to basically just copy what was already effectively a two-dimensional representation of the world, just by sketching it here. So it's an example of how technological mediation allowed us to step back from the world and try to draw it more objectively. So, you know, these are problems for the old paradigm. Because if you take abstract representation as your explanatory foundation, well, it's true that we're really good at trying to abstract away from our immediate situations. But to think that that's the primary function of perception, and to generalize it to pretty much all perception. Perception is information processing of an abstract, you know, maybe Newtonian physical world. I think that's misguided. It misconstrues the perceptual worlds of human and non-human organisms, which are normally inherently meaningful and structured in relation to their sense-making. So we have new questions. If cognitivism you know, starts from this, well, then it insufficiently problematizes the abstraction abilities of humans. But you also have this question: if all of life starts phylogenetically and ontogenetically with the sense-making of an Umwelt, where does the human ability of neutralizing the Umwelt into an abstract objective medium come from? You know, objects and symbols cannot be the starting point, but then we have a new problem of human cognition. What is the basis for capacity for meaning manipulation to constitute these ideas of abstract and independent symbols and objects? So for me, that's the enacted challenge of human cognition. You know, to explain what cognitivism is actually just assuming from the beginning. And I'm going to try to show you with two illustrative case studies the kind of problem that Enaction is facing. So the first case study is an investigation of thought sequences by Shannon. Thought sequences are trains of verbal-like expressions of thoughts that spontaneously pass through people's minds. Happens to us all the time. But Shannon asked participants of the study to describe exactly the sequences of thoughts they were having. And so he gives one example. So this participant saw a girl who was calling her amputated dog by the name of Doni. And then he said, I had this particular thought sequence. 1, it is really frisky. 2, she should have called it Shedoni, in Hebrew for diminutive for devil. Or for short, Shed, in Hebrew, devil. And then he thought, that has meaning in English too, shed. So, but what enabled the transition from thought 3 to thought 4? This tradition here. It's that the way in which the thought was expressed in the medium of language itself became an object of thought. Right? The meaning in English too is shed. It's just that the sound was the same. The way it was expressed in sound that did the transition. So here we have a transition based on a property of the medium, not of the content of the thought. And so Shannon says, were thought conducted without a medium and governed only by considerations of content, one could think only of what one intends to and would be confined to one's already established repertoire of knowledge and belief. The articulation of thought in a specific medium and the introduction of aspects that are relevant from the perspective of content presents the possibility for the generation of novelty. So this is the inverse of the classical problem of meaning, right? How do you get out of the meaning and into a kind of abstract domain such that new paths, new connections between different meanings become available to you? So you could kind of say that this is a network cognition, because if sense-making is primary and we are always governed only by considerations of content and meaning, then how do we access the abstract medium? How can an organism, become aware of those aspects that are patently irrelevant for it, given that by definition these do not appear as part of its perceptual world? Because sense-making is always about things that are meaningful to you, right? So how do the meaningless things enter into that world? So the enactive approach really needs to explain how we can cast this kind of neutral network onto our perceptual world, which thereby enables us to traverse the semantic space more freely, so that we're not bound by considerations on content all the time. So that was case study 1, now case study 2. This is a paper by Univ on embodied metaphors. In this paper, he basically argues that many conceptual metaphors are grounded and get their meaning from our biological embodiment. And he uses this to argue for an embodied interpretation of mathematics. But just to get a general idea of what he means with the embodied metaphors, here's 2 examples. He says, the summer lies ahead of us, and the big game is now behind us. He says, taken literally, these expressions do not make any sense, because the summer and the game do not refer to spatially localizable entities. So how can they be in front of us or behind us, right? But taken metaphorically, we can use knowledge of our own spatial embodiment, what he calls a source domain, and reapply this knowledge to the non-spatial context of temporality, a target domain. So this is the idea of metaphorical mediation. And he says that these metaphors enable us to detach our thought from the immediate situation and reapply it to different domains. To quote, human everyday language displays hundreds of thousands of these expressions, whose meaning is not literal in any real physical sense, but metaphorical. These expressions are linguistic manifestations of human everyday common sense and make human imagination possible by conveying precise meanings beyond physical reality. So I have 2 comments on this. The first is that these embodied metaphors are very unexpected from the perspective of orthodox cognitive science. Because if cognition is computation, then cognition should be logically independent from the mind's embodiment, especially in the case of highly abstract cognition such as mathematics. But there's also a problem. Because how can an organism that is directly locked into its own world of significance appreciate that some meaning is not to be taken literally? So even though Univ says that metaphors enable human imagination, I think he's wrong. They extend human imagination, but they already require something like imagination to be in place in the first place before we can even appreciate what metaphors are. And in order to illustrate this, I'm going to refer to Hans Jonas again, who has a very interesting example to make this point in his book of the phenomena of life. So he says, if you consider a scarecrow, the birds in the field presumably either perceive it as a threatening person, or if the deception happens to fail, maybe a convenient place on which to land and perch. So, to illustrate, if we had a human audience, then they would recognize that this is Lady Gaga. And again, if we had a human audience, then they would recognize this as a representation of Lady Gaga. But now, in the case of the birds, they would see the scarecrow as a crazy, scary human. Or, if the deception fails, maybe just a nice place to sit on. But I would hold that, with Hans Jonas, that at no point do the birds see the scarecrow as a representation of a human being. But that's precisely how we perceive it, namely as a physical structure representing a person. So what the enactive approach needs to explain really is how we can perceive something as being that something and not being that something at the same time. So this is the enactive problem of symbolic representation. But, you know, it should be remembered that orthodox cognitive science does not have the answer to this problem either. In fact, so far it has even failed to ask the right questions. Because if we follow cognition and assume that the perceptual world is a barren physical space devoid of any significance, and if cognition is already conceptualized as manipulation of abstract symbolic representations, then neither the neutrality of human perception nor the possibility of symbolic representation can be adequately problematized. So what this shows is that orthodox cognitive science does not have such a strong grip on the domain of human cognition as is often presumed. So there's a real opportunity here for enactive cognitive science to do some good work. And I will just try to sketch some ideas that I have on how we could maybe proceed on these problems that I've outlined in this section of the talk. I'm going to try to argue that maybe what's special about human cognition, we could try to conceptualize as second-order sense-making. So what do I mean with this? We have, in the previous section of the talk, identified what needs to be explained regarding the specificity of human cognition. In the words of Pablo and Gaga, we need to explain the development of a capacity to unstick meanings from a given situation and stick novel ones onto it, to put it graphically, or generally the capacity to influence meaning generation. So human sense-making is normatively guided regulation of primary, situation-bound sense-making. In short, the speciality of human cognition is to enact second-order sense-making. It's the sense-making of your sense-making. What do I have in mind with this? I'm going to try to give you some examples. So, first, linguistic mediation. Here I'm giving you some quotes to kind of like give you a flavor of the kind of work that we can do here. The first one is by Didier Bottino. He says, speaking is an alternative cultural medium that can override the natural medium and be utilized to control inactive experiencing instead of letting the physical world decide what should be lived by humans. And then John Stewart says, language characteristically has an effect of taking a distance from the action itself. To put it crudely, as long as two people are hurling verbal insults at each other, they have not actually come to blows. And here's Bottino again. He says, words may refer to notions that cannot be treated as entities or events, but to sensations, emotions, and abstract categories born out of highly heterogeneous experiences with no material core. And we might think that, oh, we're talking about linguistic reference here, so is then it right? Are the representations lurking around the corner? But not so. Bottino says, speaking does not refer to the world, it causes an experience. So in that sense, language is a form of second-order sense-making. And I'm going to suggest another example. So in his paper, Bottino describes a situation that he saw at a French skiing resort. And it's a mother playing with her 2-year-old son, and there's the dad somewhere in the background, and she says, look, this is snow, look, it's white, it's cold, it sticks, you can pick some up and make a ball and throw it at daddy, look, splash. At which point the family bursts out laughing. And Bottino perceptively analyzes the effect of the mother's utterance on the infant in terms of its evocation of the sensory-motor qualities of the snow, of the physical medium. So she's picking out all these things like white, coldness, stickiness, and so forth, in order to make the medium of the experience present to the infant. But unfortunately, he does not comment on the mother's frequent use of the word look, which I think is quite a remarkable expression. And I think it's tempting to consider such a pedagogical instruction as a form of second-order participatory sense-making, perhaps. So it's the mother's sense-making, regulating the sense-making of the infant. I think here there might also be some interesting areas of future research. Now, moving from language to writing, we can find a further distancing effect. John Stewart says, in the heat of the moment, in the real time of the chanting of a ballad by a gifted orator, all sorts of collective emotional effects are possible. By contrast, writing is structurally individual and private, both during reading and the writing itself. It is thus an instrument that induces a critical distance, which dissipates collective emotion and promotes what we call objectivity. So without writing, we wouldn't have philosophy, science, technology. But it's not just because there's a record of previous ideas, but actually because having the ideas in front of you on the page gives you the space and time to really think them over and improve little bits and rewrite it and so on and so forth. So it's a new way of thinking. So now moving to an example of technology. I've already mentioned the inactive torch at the beginning of the talk. And usually what happens when I give the device to someone who hasn't tried it before, they usually find it very awkward. They find that they need to use kind of reflection, very explicit guidance of their hand. Does it vibrate right now? Doesn't it? What am I feeling? And so on. It's a very, reflective process. And the world appears very opaque. It's right at your hand where the output of the device is. You don't feel anything in the world. But soon enough, the participant will once again experience their perceptual focus directed to aspects of the world, albeit now with the aid of implicit technological mediation. And so here we have an example of how engaging with a technological device first removes you from the world and then allows you to re-engage with the world but on new terms. So technology is perhaps one way in which you can transform our sense-making. And it's not just sensor substitution technology which has a property. I would argue, along with John Stewart and others, that actually all kinds of technology have this effect on us. Maybe some have it more than others, maybe some are more implicit, but every time that we use a tool, basically we're starting to mediate or interface our sensomotor regulation with the environment. And if this is the basis of sense-making, we are actually changing our sense-making. And in this sense, Stewart et al. Say that technology is anthropologically constitutive. So all of these are examples of cultural mediation. And they're all around us. And in that sense, you could say that a system of technical artifacts functions as a collective memory that is always already there for members of a given society, but that is not part of their own experience before they themselves reappropriate it. This appropriation is performed by individuals, but the technical systems is always already social. Thus, the system mediates a process of individuation, which is inseparably psychic and collective. So you cannot really separate the individual from the social context in which it's developing. We cannot separate human cognition from its social history and its collective cultural memory. And this brings us back to the problem of representation. This is Ed Hutchins, an anthropologist who has been investigating this cultural constitution for a while. He says, many people seem to assume that the status of external representations, representations, is unproblematic. But what makes a material pattern into a representation? And further, what makes it into the particular representation it is? The answer in both cases is enactment. To apprehend a material pattern as a representation of something is to engage in specific culturally shaped perceptual processes. So it turns out that I think that an approach to higher-level cognition is not impoverished by rejecting representation. Actually, on the contrary, it's cognitivism which is impoverished. It hasn't failed to take into account the social context in which representations exist in the first place. So it's only by being blind to these conditions of possibility of representations that the cognitive core idea, namely that there are representations operative inside the brain, could have any semblance of plausibility at all. It's only by forgetting the whole context in which representations make sense as representations that they could ever think that such a thing could exist inside your head. In the contrary, for the enactive approach, high-level cognitive processes result when culturally orchestrated low-level processes are applied to culturally organized worlds of actions. So we're really in the world here. Of course, the question still remains. I've tried to argue that human cognition is constituted by our social culture environment to a large extent. But of course, it's also true that our social culture environment is constituted by human cognition. So if you have this kind of chicken and egg problem, I think there are several solutions to this, and I won't have time to go and talk about them here, but just to point them out. So we can look at the role of play in development. There's evidence that drug-induced altered states can have some of the effects that we're looking for. They can also occur spontaneously in some psychopathologies. And also there's the role of social self-organization, where we have mutual bootstrapping of individuals. So I just take it that this is an exercise in non-linear thinking. It's not, the end of it. We just have to, as Heidegger would say, get into the circularity in the right kind of way. So, to conclude, looking backwards to where we came from and how inaction differs from cognitivism, I say that the paradigm of action cannot be easily dismissed as filling in the low-level details of an orthodox cognitive science of higher-level cognition. I've tried to argue that the living and lived body cannot be functionalized. And I've also tried to say that the specificity of the human mind cannot be understood by the framework of inner mental representation. And this is important. The rejection of cognitivism does not evoke the specter of nihilistic biomechanical reductionism. Because usually the cognitivists say that they're saving the human mind from the evil neuroscientists or physicalists who wanted to reduce everything down to the physical level, and it's their symbolic, the symbolic representation which save us from that. I don't think so. I had no. In fact, it's the contrary. The enactive approach, even though it talks about biological levels, the first-person lived experience is always tightly integrated in the dialogue, actually much more so than in the cognitivist framework. So, and then looking forward, of course inaction is currently far from complete. And going from the single cell to human cognition, I've tried to sketch that in 50 minutes. Of course there's going to be a lot of gaps. But I don't think that's surprising given the young age of this community. And I don't think that the current gaps are insurmountable problems. I think they're just invitations to further explore the rich synergies between its various methods and insights. And I think there's plenty of room for discussion and dialogue on how to improve it. And just to close out, coming back to Dennett, is it too soon to predict that the computationalist representationalist theory of mind is going to share the fate of the phlogiston theory and be consigned to the dustbin of scientific history? And time will tell. But in the meantime, I think a small but growing community of inactive researchers has successfully demonstrated that it can stand on its own feet without the crutches of mental representationalism and functionalism. Okay, if you want to read more, I highly recommend this book. Many of the quotes that I was reading to you were taken from this. This came out in 2010. And some of my own work, this is the review I wrote about that book. Much of what I had to say you can find in there. And then one of our sponsors, Avant, published a kind of summary of the philosophy that I take Enaction to have. And some of the diagrams of the different concepts going from autonomy to culture comes from this paper here. And if you want to read more about the inactive torch, there's a forthcoming paper about our experiments there as well. And thank you for your attention.
So the idea that we had was that we would limit the questions to a few minutes because we have very long breaks, and so we thought it would be a good remedy to actually interact with each other. But still, we have like 5 to 10 minutes for questions. So, if you're interested, yes, Chris.
I like very much many things you're saying. Just I wanted to point out something. When you have the two agents that are interacting and looking at that as a paradigm to approach explaining human cognition, it actually also is 3.5 billion years old, because you had multicellular mats or multicellular groups of cells, when they divided, they were next to each other and they had to interact with the other as part of their environment. Then later on you get into differentiated multicellularity, which is much newer, only 800 million years or whatever, 650. But this sociality, the interaction of agents, the kind of primary intersubjectivity is maybe as ancient as life itself.
Thank you for pointing that out. Yeah, I'm going to remember and try to say something like that, that this diagram can actually be applied to also single cell interactions. And also, of course, neural interactions, right? Communication between neurons has this, maybe the same kind of structure where there might be these autonomous interaction processes happening. So yeah, I completely agree.
Thank you for a very interesting talk and very succinct graphics. I wanted to ask you a question for perhaps future discussion, a two-part question. Where should we focus our energies on? Developmental perspectives or technology or both? Which is going to be the greater challenge?
I think it's just whatever rocks your boat, really. I think there's plenty for everyone to get involved in. What interests me about the technology is that it gives us the first-person perspective. And even coming to the developmental aspect, so once we're grown up and we can talk about perception, we're already fully developed. So we're never in the process of developing a perception modality. But when you start using some of these devices, you're just thrown back to square one. You don't know how to use it, you don't know what the sensory multi-contingencies are. And then as you start learning those laws and regularities, and your perception starts changing, that gives you an opportunity to kind of experience from the inside what it is like to undergo a development of perception. So I think there might even be some crossover between those two areas.
Thank you.
Yeah, I also enjoyed the talk, especially how you're trying to run away from that. Connection is going that new paradigm. And my question, you do acknowledge that still some aspect of representations are a challenge for inactive perspective, right? You still struggle with some things. My question would be, if I think that perhaps one of the reasons is that when you talk about the world, it's a kind of a black box. That was my sense of the talk, that for example, you do not try to define, instead of the worlds for different organisms and from different inactive systems. I mean, you perhaps take a bit more into account the idea of the dynamic presuppositions of in this case, for example, biological agents. That these internal states help differentiate environments. That's an idea that Mark worked on, and perhaps that will give you more of a clue how to account for representation as a kind of internal condition state that helps an organism differentiate and thus represent.
The way I use the word representation in this talk is just as an external symbol. And that's it. And I never want to imply that there's something like a representation inside the organism. I think the only reason why you could try to think that there is such a thing inside you, if you don't understand the social context that needs to be in place in order for something to appear as a symbolic representation in the first place. If you don't pay attention to the social network that needs to be in place for something to appear as a symbol, then maybe you could think that such a thing could be inside your head. But if you take into account the social cultural background that constitutes the representation, then that move is not available. But I take your point about the does an organism have different worlds? I think I used to have the opinion that actually there is a different world for each organism. But more recently, I've been moving away from that. I think that's the kind of like radical constructivist perspective maybe. I'm trying to move more into a direct realist perspective, where it's not so much that there's different worlds, but you have a different perspective, different relationship to the same common ground, basically. But it's a kind of direct link to that common ground. Of course, coming from a particular perspective, but it's not so much that we're all in our own little virtualities, and I think that's future work to really sort out which way Enaction goes there. Because if you look at the literature, I think you can find representatives of both opinions. But I'm kind of like drifting to the direct realist side.
Didier.
Thank you very much for this beautiful talk. And since you raised the question of look, indeed there is a point in there, because of course Gaga is using look as a kind of trigger for the sense-making process. But etymologically, apparently, it seems that the verb look comes from a Proto-Indo-European root, which is the same as that of gucken in German, light, lux in Latin, and Auge. All those words in L, G and GL come from the notion of light, so that etymologically, literally, look means shed light on the object for it to shine and become meaningful. This is how you should interpret it, shed light on it. And it coincides with the old conception of visual eyesight, which is not the perception of a signal coming from the outside, but the projection of a signal which comes from the inside, and which should make the thing meaningful by reaction, just like the dolphin sending clicks to the rocks or to bounce the signal back and make the thing present. So you have a point there, indeed.
Okay, thank you.
Yeah.
Can I take you up on your interesting point about the second order sense making? I'm not sure that it's only humans that have second order sense making, because animals, you might have a sense of smell which is associated with some prey or some other creature. And in a domestic setting, if you're taking a dog for a walk, if you pick up the lead, the dog associates the lead with going for a walk. Now that spectrum of moving from association to symbolic representation, it seems to be a spectrum that starts off in the animal world.
Yeah, and Didier just gave the example of the dolphins as well, using pig sounds. That's true, yes.
So how do you see associations compared to the symbolic representation?
Yes, well, I don't want to draw a hard distinction between humans and other animals. I think many of the mechanisms are in fact the same, and but maybe there is still a difference in how these abilities are used. Maybe the dog also has some second order sense-making abilities that allows it to learn new associations and let them become meaningful and basically generate meaning where there was no meaning before, for example. But the way that we use our abilities is to actually perhaps kind of get rid of the meaning. So science, for example, would be impossible if we couldn't somehow abstract from all the meaning that we bring into the world. So Galileo was so crucial because he managed to kind of like abstract from the direct relationship with the physical world and start working in a very abstract mathematical way. That kind of second order sense making, I think, is really very uniquely human. Of course, it must have some precursors in the animal world, but we still have to look for them. But it's an interesting question, how far can we go down with this ability for abstraction? But when I look at the literature in primatology, for example, I think there's a lot of confusion because most primatologists think that the apes primarily perceive an objective reality full of, as if Newton was there and describing everything, and then somehow they would have to, project out some meaning by making some sort of reflections about what's there. But if you take the opposite perspective and say, no, actually, all the apes and monkeys primarily are in a world of sense and meaning related to their own projects and so on, then many of their findings become much more understandable. And in fact, some of the problems that apes have, for example, with imitation of symbolic gestures and so on, might come from the fact that they have problems with abstraction, not with sense-making. So it's the second order level where there might be some issues there. But of course, it requires further investigation to see what we can find in the animal world.
Last question before coffee.
In the sense that the cognitive paradigm sort of an elephant in the room, that it tended to ignore questions of meaning, consciousness, and first-person lived world. Is there a slight sense in your sketch of the enactivist world that there's an elephant in the room there that I didn't pick up on you highlighting? And that's there's a sense that in the original world, for example, the original use of the word, for example, computing, it's something we have to account for. It's part of human cognition that we can compute, i.e. we can do sums, we can logically problem solve, and yet there's got to be some way in active paradigm, if it's going to be a true description of human cognition per se, that we've got to begin to make roads at addressing these problems which have historically been easy meat for the cognitivists. Have you got any ideas on how you might sketch move in that direction?
Yes, and I think actually maybe it was in one of your papers where I came across this. Wasn't it that Turing, in order to develop his computation, was actually looking at the human life world and seeing how the people, mathematicians around him, were making the computations in the Second World War, in code cracking, and then he abstracted from that in order to make the computer. So already there we can see that the notion of computation originally is actually a life world notion, and that you can actually maybe have a look at what was going on there before it became this kind of like abstract, logical thing. Yeah, I think it's an interesting project, and it's something that we need to do if we really want to make inroads in the cognitivist paradigm. If we can suddenly say, look, we can incorporate what you're saying into us, but we can say much more about it, that's very good.
Right, thank you very much. As much as possible, we'll try to get all the slides and put them online somewhere. Coffee is a next door building, along with the posters, so if you haven't put up your posters, there are pins over there. There are quite a few posters, so try to be compact and